Hey guys, we're going to continue here with Chapter 5, Section 3 with solving systems of equations. Today we're going to be talking about solving systems by using elimination. It says you could use a system of equations to model the amount 2 students spend on school supplies. One way to solve a system is by using addition and subtraction properties of equality to eliminate one of the variables. This is called elimination. All right, so we'll look at the problem that this is based off of in just a second. The elimination method is what we're looking at. The root of this is eliminate. So we've talked about this in class a little bit, that the goal when solving a system of equations is that in either of the equations you have 2 variables. But you can't solve a system, or you can't solve an equation that has 2 variables in it. You have to have only one variable. So that's what we're trying to do, is to eliminate one of the variables so that one of the equations has exactly one variable. So let's see how this plays out. But first, how I eat fries when I'm with people. I'm going to eat one fry at a time because that's what civilized people do, and I'm a civilized person. That's in polite company, but I know how you are when you're alone. How I eat fries, 15 at a time. I try to do 30. Okay, so solving a system by adding, solve the system by elimination. Just like when you learn how to initially add numbers, so 14 plus 32, and you add straight down, just like when you initially learn how to do that, that's kind of what you're doing here. As long as your variables and constants are matched up, and the equations are written like this, you could use the elimination method to solve this. The way this works is you add straight down if adding eliminates one of the variables. Now here's what I mean. If I add these two, so 5x plus 3x is 8x. Negative 6y plus 6y is 0y, or just 0, so it eliminates the y, so I don't write that. And then here I do negative 32 plus 48 is 16. I've eliminated one of the variables, so I have a pretty simple equation to solve here. Divide both sides by 8, and x equals 2. Now remember, I'm looking for an ordered pair in xy values, so I'm going to take this, and I'm going to substitute it back in. So I'm going to have 5 times 2 minus 6y equals negative 32. It doesn't matter which equation you use, so I do 10 minus 6y. Equals negative 32. I'll subtract 10 from both sides, and I get negative 6y equals negative 42. Divide by negative 6, and y equals 7. So my ordered pair is going to be 2, 7. And again, we've talked about this as well, but I love this because you could check your answer to see if it works, and it's not even all that difficult. You could probably do it with mental math. 2 times 5 is 10, minus 6 times 7 is 42. 10 minus 42 is negative 32. It works there. Then I try it here. 2 times 3 is 6, plus 6 times 7 is 42. 6 plus 42 is 48. That one works. So we know that it works. You could check your answers on these to make sure that they're right. Okay, so this is solving a system by adding. Oops, come on. There we go. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so here's the solution I got, 0, 4. Here's my work, working it out. So you should go ahead and check that. If you got it wrong, try to find your mistake. Okay, so solving a system by subtracting. This is very closely related to addition, except for one little change. So let's take a look at this. It says, at the school store, Ricardo bought 4 pencils and 6 erasers and spent $2.60. Annabelle bought 4 pencils and 10 erasers and spent $3.80. Solve the system to determine the cost of 1 pencil and the cost of 1 eraser. So I need to set up 2 equations. So first I'm going to start with Ricardo. He bought 4 pencils at a price that we don't know, but 4 times that price plus 6 times the price of the erasers was $2.60. Then it says that Annabelle bought 4 pencils plus 10 erasers, and her cost was $3.80. Well, now it sets up, but the difference here you'll notice is that if I add these straight down, it doesn't eliminate anything. Here I'd get 8p, here I'd get 16e, and these wouldn't do anything. So the way that you handle this situation is you make everything negative in one of them, or you run through a negative sign. So really what you're doing here is you're kind of distributing a -1. So this times -1, this times -1, this times -1. And what that does is just changes the signs of everything. So when you're subtracting, all you need to do is change the signs of all these different values. So that's what we're going to do. Let me erase this and get some space back here. So by distributing a -1, what ends up happening is I go through and this is now negative, this is now negative, and this is now negative. If one of these were already negative, then it would become positive. Now, if I add straight down or I subtract these things, it eliminates one. This minus this is gone. This is -4e. And this is -1 and 20 cents. So then I divide by -4. And E equals 30 cents. So we know an eraser costs 30 cents. Then to figure out the cost of the pencil, I just take that and substitute it into one of these. It doesn't matter which one. I'll just use the, I'm going to use the second one because there's no negatives, or it has a 10 in there. Notice I'm using the original equation without the negatives. So here I have 4p plus, that would be 3 equals 380. Then I subtract 3 from both sides. 4p equals 80 cents. Divide by 4. And a pencil equals 20 cents. And then we could check these kind of quickly to see if they work. So 4 times 20 cents is going to be 80 cents. 6 times 30 cents is going to be $1.80. $1.80 plus 80 cents is $2.60. It works there. I could try it right here, but I already know it works because that's what I did right here to solve it. Okay, so you should check these, but the costs of these two different things are right here. The eraser is 30 cents, pencil is 20 cents. Come on now. All right, so here's one for you to try. The answer will be up in 3, 2, 1. All right, here's what I got. I found the small cake is $20 and the large cake is $35. So hopefully you got that. If not, go back and try to find your mistake. All right, one last thing to look at. What if you go and you look and you want to add these, but nothing actually works? You know, if I add these, it doesn't eliminate. If I add these, it doesn't eliminate. And I got to eliminate one of them. Well, what you could do in this situation is multiply everything. So like that one problem that we just looked at where I multiplied everything by a -1, it doesn't just have to be a -1. In fact, if I multiplied everything here by 2, in other words, if I distribute this 2, the equation remains the same, but it changes some values here. So I have 2 times -5 is -10x plus 6y equals -6. Okay, so this times 2 is that, this times 2 is that, this times 2 is this. All right, so now if I add this and this, it's going to eliminate. And I'm going to rewrite this equation down here just so that it's a, actually I'll just erase. Here's what I used to do to help myself keep track of everything, is I would just, after I'd done this, after I've written this out, I'd mark that out. And now I know I'm looking at this to this. So here I have this, those eliminate. I have -7y and 6y is -y or -1y. And then 2 minus 6 is -4. Divide by -1. And I get y equals 4. Then I substitute back in here. So I have 10x minus 7 times 4 equals 2. 10x minus 28 equals 2. Add 28 to both sides. and I get 10x equals 30. Divide by 10, and x equals 3. So my ordered pair on this is 3, 4. So again, I had to multiply this by 2 to get it to a point where it will eliminate. Again, you're trying to eliminate a variable by adding or subtracting. So sometimes you have to multiply everything in there to do that. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. I lied. The answer isn't up yet. I noticed a mistake when I wrote the problem. This needs to be a plus 4y. Now the answer will be up in 3, 2, 1. All right, here you go. I got 2, 4, so hopefully you got the same thing. If not, go back and try to find your mistake. I believe that's it for today, so I'll see you in class.